Okay, this is the video tutorial for homework for lab section 54. The homework for 54 and 53, labs 54 and 53 are identical, except that people in 53 had to submit problem 1, and you guys, lab 54, you have to submit problem number 2. Now, this problem is done in the book. The only thing is that I did not use symmetry in that problem. You have an aluminum and steel strips, call it bimetallic strip, which are glued together somehow using some kind of an adhesive, etc. And one end of this thing is clamped, and then this entire structure is subjected to a temperature rise of 50 degrees Fahrenheit above the room temperature. Okay, is subjected to a uniform temperature of 50 degrees. I really should say that this is uh, above the room temperature. Okay, so please, uh, this is to be changed. Okay, subjected to a uniform temperature rise of 50 degrees. Temperature rise. In other words, if this thing was in room temperature, I raise the temperature of the room by 50 degrees, so the temperature that this object is subjected to is 50 plus room temperature, which is around 68 degrees or 70 degrees. Okay? I'll talk about that later on. Okay, good. Temperature rise. Okay. Well, actually, it said uniform temperature rise. Obviously, temperature rise means that it's above the room temperature. Okay, so let's go media. First of all, by symmetry, you know, I hope you know that you need to model only half of this, half of that. Okay, so when it comes to in the book, the whole thing is modeled, but here instead of the depth of 1 inch, I do half an inch. Okay, and then the length, of course, is the same. So let's start with a product file, not a part file, a product file. That's the way I do my assembly problems. I've done it in the class. Immediately save it, file, save management, save as desktop, new folder. This is homework 4, lab 54. 54. And I want to remind you, this is problem 2. Problem 2. Let's give it a name. ID number 1, 2, 3, 4, 5, 6, 7, 8, 9. And your name is Euler. This is homework 4. And it's lab 54. Lab 54. And this is problem 2. For those people who want to see problem number 1 done in your lab, you should go to the video for lab 53 and watch it. Okay, and I advise you to do that. Strongly advise you to do that. So this is problem 2, right? Okay, good. The parts are very simple. Basically two boxes. So insert, new part in there, and let me call this thing aluminum. Where's the aluminum? Is it aluminum top? Okay, right click properties. Call this thing top aluminum. Okay, and this is the instance name. The part name is down here, top aluminum. We'll make it. Let's make it. Double click on the part. You're in part design, you can make it. So on that convenient plane, I will sketch a rectangle, and also the size of the rectangle is 6 by 0.5. So 6 by 0.5. So let's make it. I'll do it like this. Dimension. This is 6 inches. 6 inches. And the width here is 0.5. Half the thickness of the strip. And this is, I'm going to make it on the top, so I'll padded up by, what's the height here? 0.25. Okay, so 0.25. Okay, so this is the aluminum piece. Why don't we, while we are at it, we apply material properties of aluminum to it. Apply material, metal, aluminum on this part, not on the assembly, on this part, either here or there. It really doesn't matter. Okay, and by the way, let me make the color of this thing different so that we can see it better. So properties, can I do it here? Graphics, yeah, let's make it yellow, top on yellow, aluminum is yellow. Good, good. So now we go here, insert the next part. Now, by the way, if you want to save this part, you can do file save management, but the alternative is you go to top level assembly and just click on the floppy, so it will automatically save that top piece for you, top part for you. So insert a new part in there. We say no, right click. I'm going to call it bottom steel properties. I'm going to call it what is that, product? Okay, right there. So we go bottom steel. That's the part instance name. This is the part name, bottom steel. Okay, very good. You say okay. We go make it. Double click on this. On a convenient plane, on that horizontal plane, XY plane, just like before, I'm going to draw a rectangle exactly that size. Or what you can do is you can project that face. Okay. So that's basically, you have your stuff here, right here. This is this, cancel that. If you hide this, no, sorry, that's not what I meant. If you hide this, there is the thing that you projected, and you're going to pat it in the opposite direction, make it out of steel. So you select that, you do it like this, opposite direction, and 0.5, no, 0.25, not 0.5, and there we are. Let's also change the color of this. Well, actually, we can leave it like this. Let's bring the aluminum into the show mode. There we are. So this is the aluminum, this is the steel. Apply material properties to this bottom one, to this, make it out of steel. You say okay, and we're good. Okay, good. So you want to save everything, go to top level assembly, save it. There we are. And now we're going to go to generative structure analysis. CATIA will see two parts. It's going to mesh it, both of them. Let me make these things smaller. Double click on this. 0.2. Excuse me. 0.2. Okay, the other one also 0.2. We are using linear element because I want to do this thing very fast. Actually, you know what? Make it smaller because it's linear. So I'll make it 0.1. It's going to go very fast. And 0.1. Okay, very good. If you want to look at it, right click mesh visualization. Change the rendering. There we are. So some of the stuff is for the element above, some are for below. By the way, I can change the color of these elements so you can see it. But remember the top one, I made the yellow in color of the part. I can change that to, instead of bluish like this, I can change it to a different color so that we can easily distinguish. Oh no, I make it also yellow. Okay, there we are. There we are. Okay. Now remember, I didn't have to make it yellow just because I made the part yellow, but I decided to do the same thing. Very good. Deactivate this plot. Okay, good. Now, we said, let me put this thing in the isometric view. One end is clamped, so these two ends are clamped. So let's use a clamp here. This and that, these are clamped. And the whole thing is subject to a temperature rise, of 50 degrees above the room temperature. Now, that's our load basic. That is our thermal load. If you look here, pressure, force, acceleration, no, this is and force displacement. This looks like temperature. You click on it, and it says, okay, what is the support? Obviously, these are both subject to temperature rise, and right now it says 118. Let me leave it like that. I'll tell you where the 118 is coming from. Okay, just 1 second. We say okay, but notice that as soon as I clicked on this temperature, some line appeared here which says environment. Double click on it. It tells you what the room temperature is. Initial temperature 68. So the 50 is going to go on top of that. Okay? 60 is going to go on top of that. So it's going to be 50 plus this is going to be 180. That's where I got that 180. If I had said a temperature of 100, let's say that if you said 100-degree temperature rise, then it's going to be 100 plus 168, and that value that you put for T is going to be 168. But we said 50 here. We say good. That's fine. Now, let's save our analysis. File, save management, analysis, save as, in the right folder. This is not the right folder. Don't fall. Oh, this is the right folder. Yeah, sorry, this is the right folder. Homework 4, Lab 54. That is the right folder. Okay, so let's see now. 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Euler dash lab homework 4 dash lab 54 dash problem 2. Okay, say okay. Now, say okay. If I run this thing, it will run, but there is a problem with it. I'll show you what it is. So let's run it. You have a piece of aluminum and you have a piece of steel which are supposed to be glued together, bonded together, and you're subjecting it to temperature rise. It did run. So let's look at the deformation. Look what happened here. So the top one was aluminum. It had a higher expansion coefficient, thermal expansion coefficient. It went more, grew more, and the bottom is steel, which has a lower coefficient of thermal expansion. It grew less. The reason this happened is that these two pieces they don't know of each other. The top one doesn't know there is a bottom one. The bottom one doesn't know there's a top one. They don't know that they're glued together. So we have to create an interaction between them, a connection between them. So here's what I'm going to do. I'm going to deactivate this. This is something that you'll have to do in assembly problems, interaction. Deactivate that, sorry, deactivate this. Okay, and let me change the rendering here. These colors hurt my eyes. So you create a connection between the top face of the steel and the bottom face of aluminum. You create a connection between them, and then you declare it as fasten. Fasten means that they're glued together. If one moves, the other one moves too. So here is the analysis connection. Let me hide the top one. First component, the top of the face of this steel. Second component, make sure you select this. Get the other guy in the front. Let me bring this thing in the front. Hide the steel. The bottom of this, right there. So it creates a connection between these two faces. Okay, let's get the steel here. Let's bring the steel into the show mode. Okay, there we are. Okay, so we did create a connection. It's right here. I want to show you. There we are. It's a good idea to give these things meaningful names. Okay, top of the steel, bottom of the aluminum. It put a little red dot here too, which tells you that there is some kind of a connection between them. These are the T's. Let me hide the T's. Let me hide the T's. There, okay. And let me hide these guys too. So right click, hide this, and hide that. There you go. This is that connection that you created. And that connection we're going to call it to be fastened, as if they were glued together, as if they were welded together, as if they were bonded together. So the fasten is the third one, fasten connection property. You select that connection, the connection that you created right there. Notice that it puts something that looks like a fastener sign here, and say OK, save it. First save it, save it, and then run it. You'll see that these two will move together, and because they move together, it will actually bend. It will bend. Now, let's think about it for a second before we go any further. This thing wants to grow longer than than the steel. So this grows longer, this grows less. So this will actually bend down. Pray. There. And there we are. They go together. And change the rendering to material shading right there. You can see that. So you can animate it. Uh, Before, these were growing independently of each other. However, because they're bonded together, they can't go, and this is why this is bent. This is the basic idea behind one of these old mechanical thermostats that people were putting in, heater adjusters and things like that. Okay, the only difference between this problem and the one that's done in the book, oh, oh, I forgot, surface slider. Oh, oh, I lost 5 marks. Okay, so let's deactivate this. My God, see, it happens to all of us. Remember, I made a cut here. It looks the same, but it is not right. Okay, so surface slider here, surface slider there. Good, and save it and run it. There is a difference of 5 marks between what I just didn't do and what I just did. As simple as that. Well, okay, out of 25, you lose 5 marks. Everything else you have done, okay, 20 out of 25 is respectable, right? But it's not full mark. There. You might say, wait a minute, these look the same. I agree with you. Numbers are not the same, okay? The stresses will not be the same. Okay, the last thing I want to say that as far as the stresses go, you have to be very careful. First of all, the biggest stress is going to be at the root. We know this is a bending problem. And because the two materials are dissimilar, there's going to be a jump discontinuity in stress. In other words, don't expect to get smooth color for going from top to the bottom. Okay, there's going to be the discontinuity in the stress. So this is it. Let's stop this. Stop this. If you want to look at the first problem, please go to lab section 53 video.